Hello everyone, welcome to your partner in education, Agile Rank Mate. Today, we're excited to start off a new series titled Aeee Training. So AEEE stands for the Amrita University Engineering Entrance Examination. So over here, we're going to be looking at questions which would help you in, training for this exam. So we'll be looking at questions, sample questions that have been asked for this exam, and we're going to be looking at some solutions for those questions. So let's start off, shall we? Here's our first question. This one's from physics. At a point 3,200 kilometers vertically above the surface of the Earth, acceleration due to gravity of Earth in SI units is 6.66, 3.33, 5.55, 4.44. So, how do we solve this question? Well, we need to find the acceleration due to gravity above the Earth. So it's above the surface of the Earth. So for that, we need to know the radius of the Earth. Well, in questions, you can use the standard value of the radius of the Earth, that is r, as 6.4 into 10 raised to 6 meters. And in order to solve this question, you would also need to know the acceleration due to gravity at the surface of the Earth. The general value that we use is 9.8 meters per second squared. We also need to find the new radius, which is r plus h. Now, what does this new radius stand for? Since we need to find the acceleration due to gravity at a point above the Earth, we're going to consider the Earth here, and then we're going to consider a second sphere on top of it, and its radius would be the radius of the Earth plus the height, so r plus h. So that new radius would be 3,200 kilometers plus the radius of the Earth. Now 3,200 kilometers can be written as 3.2 into 10 raised to 6 meters. So the new radius would be 6.4 plus 3.6, which would be equal to 9.6 into 10 raised to 6 meters. You can add those two. 6.4 plus 3.2 would give you 9.6. And then we need to find the acceleration due to gravity at a height h. So the general formula for acceleration due to gravity at a height would be equal to the acceleration due to gravity at the surface, which is 9.8, times the radius of the Earth squared divided by the new radius squared. So what we're having essentially is 9.8 meters per second squared, and then in the brackets you'll be dividing 6.4 into 10 raised to 6 the whole squared over 9.6 into 10 raised to 6 the whole squared. Now, in order to make our calculations easier, we are going to write it in this format. 6.4 squared would be the same thing as 6.4 multiplied by 6.4, and then 10 raised to 6 squared would be 10 raised to 12. In the denominator, it'll be 9.6 times 9.6, because, squared is basically multiplying a number by itself, times 10 raised to 12, because 10 raised to 6 the whole squared is 10 raised to 12. So as you can see, we can cancel that value from the numerator and the denominator. Then we have 6.4 and 9.6. Now, both of these can be divided by 32 because, 3.2, because 3.2 times 2 is 6.4, 3.2 times 3 gives you 9.6. So therefore, we can write the fraction in the brackets as 0.2 squared over 0.3 squared. So 6.4, 3.2 goes into 6.2 twice, and here again it goes 0.3 times. So 0.2 squared over 0.3 squared is what we find in the brackets. So again, we can, you know, square them. 0.2 squared would give you 0.04. It's the same thing as 4 into 10 raised to minus 2. Similarly, 0.3 squared is 0.09, which is 9 into 10 raised to minus 2. You can cancel those two from the numerator and the denominator. So what we get is 9.8 times 4 over 9. So we can do its multiplication here. So 9.8 times 4. So it falls 98 times 4. We can do 98 times 4 and put the point in that. 8 falls 32. 9 falls 36. 36 plus 3 is 39. So 9.8 times 4 is equivalent to 39.2. So now the acceleration at due to gravity at a height would be 39.2 divided by 9. So let's divide 392 with 9. So 9 times 4 gives you 36, gives you a remainder 3. Then you have 9 times 3 gives you 27. So when you subtract that, you get 5. And then, 9 times 5 gives you 45. And then, etc., etc. So what we're ending up as the answer for this question would be 4.35 meters per second squared. Now, the value that we get is, very close to option D. That's 4.44 meters per second squared. The SI unit here is again meters per second squared. So option 4 is the correct option. The other options are incorrect. So when we divide 39.2 with 9, we just need to get 4 to, understand that option D is correct. So you can stop the division after the first step itself when you get 4. So then you would know that all the other options are incorrect, and option D would be the right answer. So at a point 3,200 kilometers vertically above the surface of the Earth, the acceleration due to gravity of the Earth in SI units is 4.44 meters per second squared. Now let's look at another question. If the charge Q in a capacitor is doubled, the electric field energy stored inside would double, increase by a factor of 4, remains unchanged, increase by a factor of 8. Now let's look at the energy stored in a capacitor. Now the energy stored in a capacitor is expressed by Q square over 2C. So therefore, in this equation, we can see that the electric field energy is directly proportional to the square of the charge Q. So if the charge Q is doubled, let's write that down as an equation, as a ratio. So E1 over E2 will be the same thing as Q1 squared over Q2 squared. Now if Q2 is 2 times of Q1, then what we get is E1 over E2 as Q1 squared over 2Q1 the whole squared, which is Q1 squared over 4Q1 squared. You just have to cancel those to get the ratio as 1/4. So that means E2 would be 4 times that of E1. So if the charge Q in a capacitor is doubled, then the electric field energy would increase by a factor of 4. So option B is the correct option. The other options are incorrect. Now some people do answer it as option A, doubles. They use the formula QV over 2. But then the V the V here, that is the electric potential, can be written as Q over C again. So Q times Q over 2C, that becomes Q squared over 2C. So when we are relating the charge Q with the electric field energy, we should not use the formula E equals QV by 2. The reason being that the value of V also contains a Q. So therefore, the correct equation that we should use is E equals Q squared over 2C. So therefore, option B, increases by a factor 4, is the correct answer instead of doubling. And that's because you have to use the correct equation, which is E equals Q squared over 2C. Now let's look at another question of physics. A parallel plate capacitor is connected to a battery supplying constant voltage difference such that it accumulates a charge Q. Now, while being connected, if the separation D between the plates increases, then we need to find out whether the electric field inside the capacitor and the charge, whether they increase or decrease, and how do they do it with respect to the other. So, in order to solve this question, we would need to relate the capacitance with the separation, and we also for that we need to understand, whether the electric potential energy, electric field, it increases or decreases with respect to the distance. So capacitance is related with the separation between the plates through this formula. Capacitance C equals E naught, which is permittivity, times area of the plate over the separation D. So therefore, capacitance is inversely proportional to let's say capacitance is inversely proportional to the separation. Now the capacitance can be related with the current like this. So C is directly proportional to Q. So therefore, when you have the decrease in the separation space, then the capacitance decreases. That means the charge Q also decreases. So we can see that the charge Q is inversely proportional to D. So the correct option would include the statement that Q decreases. So therefore we can eliminate options B and D because they say that Q increases. Now we need to find out whether the electric field increases or decreases inside the capacitor. Now, voltage inside the capacitor, V, is represented as E times D. E is the electric field. So the electric field would be voltage over the separation distance D. That means the electric field is also inversely proportional to the separation space. So therefore, if the separation space increases, then the electric field decreases. So it will be similar to the case with charge. So therefore, as you can see, the electric field has to decrease as well, which means option C is incorrect. The correct option is option A. Both electric field inside the capacitor and Q decreases. So in order to solve this question, it's important that you should know the formula that connect capacitance to the separation space, the formulae that connect capacitance to the charge Q, and the formulae that connect electric field to the separation space. All of this will help us understand the relation between charge, electric field, and the separation space. So therefore, when we use that, you can find that option A, both decrease, to be the right answer. Now let's look at some questions from chemistry. Which one of the following statements is true? An orbit and orbital mean the same thing. This is incorrect. An orbit refers to the complete shell inside an atom where an electron revolves, while an orbital is the subsection of the various subshells that we find in an orbit. So an orbital is smaller than an orbit. So therefore they do not mean the same thing. An orbit and orbital contain the same number of electrons always. The term always makes this option incorrect. So it is possible for an orbit and orbital to have the same number of electrons. If you look at the first orbit, it contains the s subshell. S subshell has only one orbital, which contains 2 electrons. So in that scenario, they contain the same number of electrons. But as we move higher, as we move on to higher orbits, then the orbit and orbital will not have the same number of electrons. So this statement is also incorrect. It's only applicable for the first shell, or the first orbit. Next, option C, the energies of the orbit and the orbital are the same. This option again is incorrect. The energies of the orbits inside are stronger, while for an orbital it depends on the subshell. If the subshell, whether the subshell is stronger or weaker, so therefore they vary. That means option C is also incorrect. The maximum number of electrons present in an orbit and an orbital will be different. This option is correct. The reason being that in the first shell, you'll have 2 electrons. In the second shell, you would have a maximum of 8 electrons, while in the third shell, it can go up to 18 electrons. Whereas for an orbital, it would be always 2 electrons, because an orbital is basically the square where you have oppositely spinning electrons. And since orbital is a subsection of a subshell, every orbital would have a maximum of 2 electrons, and they can either have 1 electron, 0, or 2 electrons. So the maximum number would always be different. The maximum number for an orbit depends on its quantum number. However, for an orbital, it will always be 2 electrons. So therefore, option D is the correct option. It's the only statement among the following that is true. Now let's look at another question. Which one of the following has electronic configuration in violation of the off-bow principle? Now in the off-bow principle, you have to use a certain order to fill up your electrons. 1s, 2s, 2p, 3s, 3p, 4s, 3d, and so on. So that's the order in which you should fill it up. However, one of these 4 atoms has an electronic configuration which violates this principle. So we need to find out which one of these it is. Now let's look at each of the elements. Calcium has atomic number 20, titanium has atomic number 23, manganese has atomic number 25, and chromium has atomic number 24. Now let's write down their electronic configuration. For calcium, the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. So that gives you 2, 2, 4, 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20. So that gives you a total of 20 electrons, and it's according to the off-bow principle. There is no violation. So option A is incorrect. What about titanium? Well, here goes. I believe titanium has 22 instead of 23. Vanadium has 23, in fact, so apologies for that. Titanium has an atomic number of 22. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. So as you can see, when you add them up together, 2 2s 4, plus 6 is 10, plus 2 is 12, plus 16, plus 20, plus 2, 22. And as you can see, it goes according to the off-bar principle because we're using that particular order. 1s, then 2s, then 2p, then 3s, then 3p, then 4s before 3d. So 4s comes before 3d, and it's filled up. 4s is fully filled up before we go to 3d. Now let's look at manganese. Mn. Manganese has 25. So when we look at manganese, the electronic configuration would go like this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. All of this you've already done according to calcium, and then there's going to be 5 electrons left, so you'll write 3d5. So again, options B and D are incorrect. The correct option would be option C, chromium. So as you can see, for calcium, titanium, and manganese, the electronic configuration goes according to the off-bar principle, so there is no problem. However, for chromium, the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6. So far, so good. But then we have 4s1 and 3d5 instead of 4s. So this here is a violation of the off-bar principle. If we were to use the off-bar principle, it would be 4s2, 3d4. Now, why did this happen? This is because of the Hund's rule of maximum multiplicity, where, half-filled orbitals and full-filled orbitals would have more energy. Would have more stability. So therefore, in order to have maximum multiplicity, both the S shell, the 4s shell, and the 3d subshell, both of these subshells have half the number of electrons instead of filling S completely. So therefore, this observation makes chromium having an electron configuration which violates the off-bar principle. So chromium, option C, is the correct option. Now let's look at another question of chemistry. Which one of the following changes is spontaneous? Now what do you mean by spontaneous? It means it occurs by itself. There is no change in conditions which induces the following changes. So which of these is spontaneous? Option A, a matchstick on strike burns. So when you strike a matchstick, you induce friction, and this friction induces a change in temperature. All right, sorry about that. So friction here induces a change in temperature. And when there's a change in temperature, the change would not be spontaneous. So option A is incorrect. Option B, camphor packed in a container without overspace catches fire on its own. Now camphor is one of those materials which undergoes sublimation, which means the solid turns directly into gas. So option B is also incorrect. What about option C? Petrol kept in an open beaker reduces in quantity slowly. Now we know that petrol is a volatile substance, and that means it's easily evaporated. So you don't have to, induce heat in order for it to evaporate. So therefore, we can safely say that option C is a spontaneous process. Option D, water in a beaker surrounded by ice and salt freezes. Now ice is already colder than water, so therefore it's because of ice there is a change in temperature in the surroundings that makes water in the beaker colder and freezing. So therefore option D is not a spontaneous change. So except for option C, all other changes are not spontaneous. Option C petrol kept in an open beaker reduces in quantity slowly is a spontaneous process. Now let's look at some questions of mathematics. This question is related to matrices. If 1x1, if the multiplication of the matrix 1x1, 1, 2, 3, 0, 4, 5, 0, 6, 7, x1 minus 2 is equal to 0, then we need to find the value of x. So how do we solve this question? For this, we need to use what we call matrix multiplication. In matrix multiplication, when you have two matrices, for example, 1x1 and 1, 2, 3, 0, 4, 5, 0, 6, 7, then we need to make sure that they are able to be multiplied. And in order to do that, we need to make sure that the number of columns of one matrix correspond to the number of rows in the other matrix. If those two values are equal, then we can multiply them. So when we multiply these two matrices, we would need to multiply the first element here with the first element of the row, then add that with the second element of the first one multiplied by this one, and so on. So when we do this particular matrix multiplication for these two matrices, 1x1 and the 9-element matrix, what we get is 1 times 1 plus x times 0 plus 1 times 0 as the first element for the new multiplied matrix. The second element would be the first row multiplied by the second column. So that will be 1 times 2 plus 4 times x plus 1 times 6. And then finally, the third element would be the first row multiplied by the third column. This would be 1 times 3 plus x times 5 plus 1 times 7. So this is how the multiplied matrix would look like. When we add all those elements together, 1 plus 0x plus 0 gives you 1. Then you have 2 plus 6, that's 8, plus 4x. And then you have 3 plus 7 is 10, along with 5x. So this here is the multiplication of the matrices 1x1 and 1, 2, 3, 0, 4, 5, 0, 6, 7. So once you got the product for these two matrices, you'll have to multiply that with the third matrix, x1 and minus 2. And the product of these three matrices is given to be 0. So let's look at another page. We have 1, 8 plus 4x, 10 plus 5x as the first matrix, and it will be multiplied with x, 1, and minus 2, and its product is already given to be 0. Now 0 means that all the elements in a matrix would be 0. That's called a 0 matrix. It can be of order 2 or 3. So when we before multiplying these two matrices, we need to make sure that they're compatible. So here we have 1 row and 3 columns, and in the second matrix we have 3 rows and 1 column. So the number of columns here would match up with the number of rows here. So that means we can multiply it to form a 1 by 1 matrix. So when they multiply, it'll be 1 times x plus 8 plus 4x times 1 plus 10 plus 5x times minus 2. And this would be equal to a matrix with the element 0, and it's a 1 by 1 matrix. So this is what the product would look like. So when we solve the left-hand side, we get x plus 8 plus 4x minus 20 minus 5x. So 4x, I'm afraid it's not 5x, it's minus 10x. So let's erase that part in order to make it clearer. So instead of 5, it would be 10. So x plus 8 plus 4x minus 20 minus 10x is on the left-hand side. The right-hand side would be a zero matrix. So x plus 4x is 5x. 5x minus 10x would give you minus 5x. And 8 minus 20 would give you minus 12. And that is equal to the zero matrix. Now, since the matrix on the left is equal to a zero matrix, then the element inside would be equal to 0. So that's how we solve it. So therefore, minus 5x minus 12 is equal to 0. So therefore, minus 5x would be equal to plus 12, which means x would be equal to 12 over minus 5, which is the same thing as minus 12 over 5. So the value of x is minus 12 over 5. Now, if we look at our options, it is clear that minus 12 by 5 is the same option as option D. So therefore, the correct option for this question is option D. And the way to solve this is by using matrix multiplication. So we multiply the three matrices using matrix multiplication. We equate that to a zero matrix, and then we find the value of x. And that's how we solve this question. Let's look at another question. The arithmetic mean of n odd natural numbers is n times n plus 1 over 2, n minus 1, n squared. Let's understand the question. We need to find the arithmetic mean of what is called n odd natural numbers. So n odd natural numbers would mean a series containing odd numbers, 1, 3, 5, 7, etc., up to a number n. So this series is basically what we call an arithmetic progression. And identifying it as an arithmetic progression is important because then we'll be able to find out the first element to be 1, the distance between the elements to be 2, etc. And why do we need that? Because we need to find its arithmetic mean. And the arithmetic mean is sum of the terms over number of terms. Now, we don't know the sum of the terms of n odd natural numbers because we don't know the value of n. But we know that it's an arithmetic progression, so therefore the sum of terms for an arithmetic progression would be the formula n by 2 over 2 n by 2 multiplied by 2a plus n minus 1 times d. This is the formula for the sum of n terms. So the sum of n terms, when we replace a with 1 and d with 2, we will get n by 2 times 2 times 1, that's 2, plus n minus 1 over d is dn minus d. D here is 2, so therefore we would get 2n minus 2. So 2 minus 2 is 0. We have n by 2 times 2n as the sum of n terms. So 2 cancels out with 2, n times n gives you n squared. So the sum of n terms of the arithmetic progression of the first n odd natural numbers would be n squared. So now we'll be able to find out the arithmetic mean easily. The sum of terms is n squared, and the number of terms, because we know it's the first n odd natural numbers, the number of terms would be n. So the arithmetic mean or average is n squared over n. N squared is n times n, so we can cancel one n with the denominator. So the final answer for the arithmetic mean would be option A, n. So n here is the correct answer. Now B, C, and D are incorrect because n minus 1 is basically, the order of the progression. Then we have B, which is n times n plus 1 over 2. This is for, two numbers. And n squared was basically the sum of the n terms that we know, that we found out, which is by using arithmetic progression. So for the previous question, it was clear that option A is the correct option. Now we will look at this question. 3 vectors, A, B, and C, are given by I cap plus K cap I cap plus j cap plus k cap, and 3i minus 2j plus 5 respectively. Then the vector r, which satisfies the equation r cross b equals c cross b and r dot a equals 0 is. So we have 4 vectors, which are possible vectors, possible solutions to the vector r. We need to find out which one of these is correct. Now let's write down each of the vectors so that we can understand them. Vector A is given as I cap plus k cap, so that means it's I cap plus 0 j cap plus k cap. Vector B is I plus j plus k. Now I, j, and k are unit vectors, which you will study in vector algebra. The vector C is given by 3i minus 2j plus 5k. Now, we know that the values of the vectors A, B, and C because they're given. We don't know the value of the vector r just yet. So what we're going to do is we're going to consider vector r to be equal to xi cap plus yj cap plus zk cap. X is the x coefficient, y is the y coefficient, z is the z coefficient. So basically what we're going to do is to find out x, y, and z. Now how do we do that? We are given 2 equations involving the vector r. We're going to use them to solve this question. Now let's look at the easier question here. In this question, we're given a cross product and a dot product. Now the dot product equation given is this. The vector r dot product with vector a gives us 0. Now 0 here is a 0 vector, so since the dot product of the vectors r and a is a 0 vector, then it is clear that the modulus of that dot product would be the value 0. Now the modulus of any dot vector would be multiplying its x coefficients, y coefficients, and z coefficients, and then adding them together. So for vector A, it's 1. For vector r, it's x. Similarly, for the y coefficient, it's 0 times y. And for the z coefficient, it's 1 times z. All of that is equal to 0. So that gives us the equation x plus z equals 0. Now we will consider this as equation 1. And then we'll move on to the next equation given in the question, which is a cross product. So how do we solve for a cross product? Well, the easy method to remember, which we can use to solve a cross product, is by using determinants. We'll have to do 2 of those, so we'll demonstrate the first one. We know for a fact that r cross b is equal to c cross b. That is the equation given. So we need to find out the cross product for C and B, followed by the cross product for R and B. Then we'll have to equate their, coefficients together. So whenever you have a cross product, its modulus would be a determinant. Now, in this determinant, it will be a determinant of order 3 cross 3. And then its first row would be filled with the unit vectors, I, j, and k. The second row would be filled with the coefficients for the vector c, which would be 3, minus 2, and 5. Just so that you can refer to what is going on. I'm going to write those vectors in here. Alright, so since we're doing C cross B, the third row would contain the coefficients of vector B, which would be 1, 1, and 1. Now we just need to solve for the determinant, and that's easy. You've studied that in matrices and determinants. You just have to take I cap and then take a smaller determinant, minus 2, 5, 1, 1. and then you take negative of j cap, and then you find the second determinant, then you take plus k cap and find the third determinant, and so on. So when you can solve that, what you'll get would be minus 2 times 1 minus 5 times 1, so it will be minus 7. For the second determinant, you're going to get 3 minus 5, which is minus 2. And then for the third one, you're going to get 3 minus minus 2, that's 3 plus 2, which is 5. So modulus of C cross, so the cross vector C cross B would be minus 7 I cap plus 2 j cap plus 5 k cap. So this is C cross B. Now we're going to find out the determinant for R cross B. The modulus of R cross B is a determinant containing ijk, xyz, and 1, 1, 1. So when you solve for that, you're going to get I times yz11 minus j times xz11 plus k times xy11. So when you solve those determinants, these are determinants of order 2, you're going to get y minus z minus j cap times x minus z plus k cap times x minus y. So the vector R cross B would be equal to y minus z I cap plus z minus x j cap plus x minus y k cap. Now since we know that R cross B is equal to C cross B, we can write down the two cross products together. So y minus z I cap plus z minus x j cap plus x minus y k cap would be equal to minus 7i plus 2j plus 5k. Now we're going to equate their coefficients together. So what we're getting is y minus z equals minus 7, z minus x equals 2, x minus y equals 5. So these are going to be equations 2, 3, and 4 respectively. Now, in equation 1, we know that x plus z equals 0. So therefore, x would be equal to minus z. We're going to put that value in equation 3. So what we're getting z minus of minus z as 2. Z minus of minus z is the same thing as adding z to z, so therefore you get 2z equals 2, which means the value of z equals 1. So since x equals minus z, that will mean that x would be equal to minus 1. Now we will put x equals minus 1 in equation 4. So what we're getting is minus 1 minus y equals 5. So therefore minus y equals 5 plus 1, that's 6. So therefore y would be equal to minus 6. So the value of x is minus 1, the value of y is minus 6, and the value of z is 1. So therefore the vector r for this question would be equal to minus I cap minus 6j cap plus k cap. So this is the vector that would satisfy the two products, the dot product r bar dot a bar and the cross product r bar dot b bar being equal to the cross product c bar dot cross b bar. So this is the final vector that we need to find out. The vector r would be equal to minus I cap minus 6j cap plus k cap. And as you can see in the following options, it is very clear that option A is the correct option. And this is done by finding out the dot product and the cross product according to the equations given in the question, and then equating the coefficients to find the answer. So that concludes this episode of AEEE Training. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to Agile Rank Mate, your partner in education. If you want to get our latest updates, then don't forget to hit the bell icon that's present below the video so that you'll get notifications. Until the next webisode then, take care, stay alert, bye-bye for now.